BeyondX is an annual design festival, and over the next 2 days, we have lined up prestigious speakers from around the world, showcasing fresh technologies that truly pushes innovation. So welcome to our very first session, Digital Eyes on Site. So I'll just introduce you to our speakers for today. Our very first speaker, Saw Pei Ling. She's the Sales Director of Trimble Solutions. And Pei Ling brings more than 10 years of structural experience to the region with in-depth understanding of the ebb and flow of the built environment. She has helped consulting firms, contractors, and developers move their business forward through constructive data and through collaboration. We also have Professor David Chua Kim Huat. He's a professor and deputy head of the Department of Civil and Environmental Engineering at NUS. UC Berkeley alumni, he obtained his Masters of Science and subsequently completed his PhD dissertation on a network pavement management system. He has been involved in many consulting projects for the Mass Rapid Transit Corporation of Singapore, Land Transport Authority, and many other projects. Our next presenter, over to you, Andy.
Okay, our second speaker is Sean Koo. He's a Chief Technology Officer of H3Zoom.ai. He is a technology enthusiast that has worked with startups and SMEs on technology commercialization and go-to-market strategy, scaling architectural acoustic startup, Aural 8, AI healthcare startups, and more. Okay, next slide. Okay, just a quick reminder to all Zoom attendees, do not worry, your microphones and cameras are disabled now. If you wish to make a comment, click on chat at the bottom left. Tell us where you are from and how do you find the topic. If you want to ask a question, click on Q&A at the bottom right, then tell us which speaker to address your question. If you are tuning in via Facebook, please post your queries in the comment section and we will try to get to you. Audience question will be asked at the end of the session. Now, let's welcome to our first speaker for the presentation.
Thank you for the introduction, Sunita. I'm very pleased to be here today. Thank you for the invite. We did do this last year on location. So this is, we liked it last year and we want to come back and do more. And this time it's online. And so today's topic is on digital eyes. And for us, we're going to talk about AR, MR, and XR. And how our technology and our hardware and software can improve remote collaboration and site safety during this time of the COVID-19 pandemic. Okay, and what I wanted to do is also to share with you that we are very honored to have Prof. David Chua with all his accolades. It's very long. So if you guys have a phone and you want to know more about Prof. David Chua and what he's doing and what he's up to, please snap a photo of the QR code. Is my screen blocked by the partially by this this grid, or you guys can see my entire screen?
You're fine. Go ahead.
Yeah. Okay. All right. So like I said, I'm very happy to have Prof. David Chua to join us. He's deputy head. And what's interesting is recently, NUS has invested in the Digital Revolution Fund, which is handled by Prof. Chua. And so hence, there's a lot of good technology that's being adopted here locally in NUS. And we also invited our research trainee, Mr. Leonard Loan, and he's going to join us later. He's going to do the demonstration on the XR10. So if you can see my screen, I'm not sure you can see this guy with a weird headset. Okay. So this is Leonard. Leonard, say hello. Okay, so he will be doing the demonstration later on. So before we start, I would like to give this opportunity to Prof. Chua to speak a few words and to share with us what's his aspiration with this Digital Revolution Fund. Prof. Chua?
All right, thanks, Pei-Ling. I just want to thank Pei-Ling for this collaboration with Trimble. And the digitalization, actually the lab there is actually is to support two programs that we have. One is a UG, undergraduate specialization. It's a digitalization in urban infrastructure. It cuts across all the civil engineering disciplines and including construction. And then we have another support here. I mean, the lab is support the graduate certificate and on digitalization and technology for construction. So if, I mean, look out for this grad cert enrollment, right? There are several courses that actually enable the students to be able to use the technology and to be equipped with it. Now, a little bit about myself. Actually, I'm also I really am enthusiast in lean construction. Actually, I'm also the co-founder of Lean Station, all right? Over about a software, Lean Plan Do's. Many of the projects have been conducted with Lean Plan Do. And I'm also interested in computer integrated construction that was in the past. Now, with the digital technologies, I'm very much involved with autonomous drone, deep learning, AI for defect detection. And then, you know, one of the important things that I find is that technologies is insufficient in itself. The processes that surrounds the use of the technologies are very important. And this is where I think digital technologies, although it is there, it has to be intertwined with the fact of how these processes need to be conducted. There needs to be a rethinking about the use of the technologies within the processes. So there's a much needed improvement, I believe, in workflows and across the whole building life cycle. Construction as a whole is still among the least digitized industries. And I think here is where I would like to be able to collaborate with industry partners to be able to see the transformation in the industry, in the use of digitized technologies to improve our workflows. Now, it is challenging because people are very used to the old ways of working. It's always challenging to introduce any new system or tool into an existing process and to ensure successful adoption, right? We see that in the Lean Plan Do as well. So there needs to be a cultural shift. And I would like to be able to participate in this with the industry. Now, today we will look at this AR. I mean, that's where Leonard, my research trainee, will be helping to demonstrate the use of this AR. Is actually part of this whole idea of extended reality. Now, broadly, AR really facilitates communication, enhances collaboration. I think it assists our workers, increase productivity and effectiveness, improves safety and training. And so what I would like to do is to be able to invite industries, companies, to be able to collaborate with us at NUS, the Department of Civil and Environmental Engineering. I have former students working on final year projects. We did virtual tagging on objects and defects on the in the work site. Then there is the virtual layout of site, and then even the use of the AR for virtual fittings, right? So I'd just like to end by, again, inviting collaborations, and I hope that we can move the Singapore construction industry or even locally in the region here towards this idea of adopting digital technologies in their processes to make us a more productive and more efficient industry. Thank you, Pei-Ling, over to you, back to you.
Thank you, Prof. Chua. It seems like you are interested in everything and anything, right? Okay, so for those who are interested to work on any R&D projects or interested in what we're going to talk about later today, kindly please contact either of us so that we can, help you out and we can get some case studies and work groups going locally, right? And as Prof. Chua and as the BeyondX group has mentioned, this session is all about new technology. And in fact, this technology is so new that we only just received this years, I think 2 weeks ago, 3 weeks ago. Okay, and so we managed to set it up and at the 11th hour, in fact, really, without a joke. So without further ado, I'm going to move on because I have quite a lot of slides to cover. And I always like to start with Trimble because a lot of people know our software, our product, but you don't know our company. Okay, so you know SketchUp, which is our product. You know Tekla, which is our product, but you don't know Trimble. So I want to take a few seconds just to give due credit to our company. It's a great company. It's a technology company. It's a very huge company where we develop our own technology. We sell it, we market it, and we support the customers throughout the whole journey. Okay. So this is just a snapshot. If for anyone who's interested, we are publicly listed. You can invest in our company and you can find out more. Everything is black and white on site. And what's interesting is our business is not just covering just a small part of technology. So we're bringing technology to agriculture, building, civil and engineering, geospatial, as well as transportation. Now, today's focus is mainly on the mixed reality, which is not even mentioned here because it's such a small bits and pieces that actually glue everything together. So which is bring us to how Trimble actually transformed from a GPS navigation system, positioning system for surveying, into productivity where it involves heavily on development of software. And nowadays we're talking about integrating the different software, including third-party software. Okay, so we have adopted open system so that whatever we do, whoever using our product, they can integrate truly, okay? And not just piecemeal, not here and there, not pieces, yeah? So when we talk about integration, this brings us to the main topic, which is the challenges that construction, whether it's on site or pre-construction that we face, even before the COVID-19 pandemic, okay? So addressing these challenges is in itself a huge task, all right? And these are just some of the things that stands out for everybody who's involved in construction. Okay, there's a lot of gaps in terms of technology, in terms of silos. You know, stakeholders are holding their own responsibility, and how can we break through from these silos so that we can really work together as one team? Yeah. So lack of collaboration, even within the same company. ONG&ONG is a very big company. You have architecture, you have M&E, you have structural, and you have, you know, your clients and your contractors that you work with and the subcontractors that the contractors work with. So there's a lot of disconnect between the office and the field, right? And between the different stakeholders, right? And the amount of time spent on collaborating, coordinating, and in effect, is not effective enough to avoid rework, to get it right the first time, right? And also in Singapore, we're driving a lot on prefabrication, off-site construction, and then just on-site assembly, which is what we term as DFMA, right? So how can we make use of all these and through technology, make the construction more seamless and more productive and more effective, right? And with the cost of technology going down, like for example, this year, we've actually done away with the traditional licensing for our software. We've gone into subscription, okay? So the cost of technology is definitely inducive enough for the whole ecosystem to work as one, all right? So these are some of the conditions that in Trimble, we see it as an opportunity where extended reality comes in to help solve some of these communication issues, right? And to shortcut the communication from site to office or from office to site, okay? So today, that's what we want to talk about. And the number one concern right now in today's construction site is keeping the workforce and the community safe, right? So as everyone knows, if you're in Singapore, you know that our COVID-19 clusters are concentrated at the workers' dormitories, okay? And since then, the dormitories have been cleared, but then there's resurgence of cases. And then it started to result in stop work orders as a precautionary measure. So it's a very, very testing time right now. And so what I really want to do is, how can we face the challenges, right, head on, but at the same time use technology to replace some of the old system and make sure that we can still be productive on site with fewer people, maybe not the right staff that is required to finish the job, right? How can we make it work, all right? So things like cohorting and segregation of workers, right? Getting the right people on site to finish the job is already a challenge, okay? And site walkabouts and site meetings, just to get the approval to do that is already a process on its own, okay? So if we can do away with all these on-site work, right, and we take it remotely, then we have a chance to actually play catch up, right, to whatever projects so that we can still deliver on time, all right? So firstly, before we move into the reality, the mixed reality, the augmented reality, and how we can use the data remotely, we have to look at the content, okay? And in Trimble, when we talk about digital content, we're talking about the full process, okay? So I want to share a video clip. It's very short, but it tells you exactly what's our processes and why it is successful, okay? So I hope if everybody can hear this.
There's a digital transformation underway, and the new way to work is leading it. It's called the Constructible process, and it's optimizing the entire design, build, and operate lifecycle. Here's how. Trimble's Constructible process focuses on 3 key areas. All phases and trades are connected. Models and workflows are content enabled, and constructible models drive smart workflows. The first C, connected, is collaboration at its core. It allows information to flow back and forth freely for successful on-time project completion. Cutting-edge technology enables connectivity across
I think you're having issues hearing the video, Pei-Ling.
Oh, you can't hear it?
Yeah, I think let's move on. Yeah, running a bit late, so let's move on.
Okay, so what we're trying to say here is we have the right content, which is digitalized and it's on cloud that everybody can use and share at the right time with the right information to the right people. And this will help us to plan and be connected in whatever we do, whether we are using the data for day-to-day or we're using the data to extract, precious planning information or to create to allocate resources. Okay, so the constructible process is not new. It's already been implemented successfully in many companies. Okay, now so we have been building all these models, right? Everybody in Singapore must have come across or must have learned how to build a simple 3D data. All right, and this data, how can we communicate? Because the architect might be using another technology, another software, and your contractor may be using something completely different. So how can we communicate? So we need another tool which can help us to gel everything together and to collaborate effectively. So these are some of the models that our users create, and these are very detailed, very accurate model. It's so detailed that we can, in fact, build what we model, okay? And build what you see, okay? So there's no discrepancy there, okay? So that's very important. The content has to be there. And so with the right content, we can do a data-driven collaboration. And when I talk about data-driven collaboration, I'm referring to our Trimble Connect solution, which is actually installed on our XR10, which you will see later on. Now, during the COVID-19 pandemic, we actually surpassed 10 million users on 3rd June 2020, and everybody is trying to collaborate on cloud. And this is the most efficient and, in fact, the cheapest way to do it, okay? And it's very effective. And so this is just a snapshot of what Trimble Connect does. You can use it on your desktop, on your tablet, on your phone. Okay, so if anyone has a phone right now, you can in fact download a Trimble Connect app. You can load any information, is it 2D, whether it's a file, whether it's a 3D model, and you can view them and communicate it straight away to the entire team. Okay, so that's how effective it is. And the first 10 GB, it's actually free of charge. Okay, so I urge you all, go and try it out if you're curious. Okay, and we have real life projects that's already been used. Like I said, we have 10 million users that surpassed already. And these are actual industrial users. Okay, so we have a lot of case studies that's online. If you need more information, let me know. We can send it out to you. Okay, now this brings me to the real topic of the day, which is digitalize, how we can do remote real-time collaboration with the content and the collaboration tool that is already available to us. Okay, so when I talk about XR, it means extended reality. It could be in the form of VR, AR, or MR. And in this episode, we are talking about MR because we actually are able to merge the virtual and digital world with the physical environment where we are at. Okay, so without much ado, I'm not going to talk too much about our products, but what is worthwhile talking about is this mixed reality can be used by the architects, by the general contractors, by the prefabricators, subcontractors, and all the way to facility management. All right. So what I want to do right now is to introduce some case studies, and then I'm going to move on to let Leonard show you what he's learned the past few days and what he can use the XR10 on. So these are some of the use cases, be it design review, pre-construction visualization, clash detection, and coordination before it goes out to site, and also on-site training, okay, and 3D management on-site of how you want to delegate the task and who sees what, and how do you want to create to-do list and RFIs just via the collaboration tool and the XR10, okay, and also for verification, QA and QC, all these can be done using our mixed reality hardware software, okay. So there's a video, but I do not want to play it because it seems that you can't hear it anyway. But feel free to let me know. I think we will share all these PowerPoint slides later on anyway. So if you guys have time, please go through it because I can't actually share the video with the sound. So this is one of the user, one of our first GA Smart buildings. And what they've done is they are situated in France, Toulouse, and they've used this XR technology for a long time and on various projects and from start to finish, okay? So these are some statistics. There's just not just beyond the savings, the dollars and cents, is the satisfaction that this technology actually works, okay? And this is a sharing from Remy Vizier, who's the leader, who's leading the team into this new technology, okay? So this is a video, again, I'm not gonna share it. So this is another video, another case study by John Manfield. What happens is they are able to incorporate even beyond what we are offering by adding the Dynamic 365, which is Microsoft, right? And so that they can do remote assistance. That means whether you're on site or whether you're communicating to someone back in the office, both of you can actually annotate on the same model, right? And create an interactive session, okay, between each other. So again, there's a video there. We will share it out if we can with the help of BeyondX team. And in 2018, before the release, this is the Pioneer project, okay? What happened is we used the XR to do a walkthrough the first run, and the savings are there because we detected clashes just through the first walkthrough. So these are things that's already happening with the technology and taken advantage of since 2018, before the actual official release of the HoloLens. Okay, and we've also used it. Our customer also use it on their production floor as a training to train new recruits. Okay, and this is also a video. This is a very interesting video to show, and there's actually a competition. We're teaching the new recruits, and then they're competing with the experts who are the rebar installers. Okay, so we're teaching the new recruits how to put all the rebars together, while the experts are also putting it together at the same time. And guess who won? The new recruits who have no clue what they're doing. They just follow the steps, and they're able to get the job done faster than the experts. Okay, so it meant a lot, and they've actually proceeded to continue with this kind of training. Okay, so right now I'm going to hand over to Leonard. Okay, can you share and Leonard's going to share his screen so that you can see what he actually sees inside the XR10. Yeah, you can see. We can see your what you're seeing right now. Yeah. Okay. So what we're going to do first is to show you that a big project, when it breaks down to a precast module, okay, and we have the information, then we can actually view it using the XR10 on site or at the fabrication floor. So this is a very simple model. You want to open up the model of just part of the trellis, the balcony, which is a precast component and is fabricated offsite. And every bits and every pieces was actually transported on site for assembly. Okay, so this whole entire thing with the rebar and the concrete elements, these precast elements, is all done at the fabrication, the factory floor. And then it's shipped from Malaysia, JB, all the way to Singapore for installation. Okay, so how this was made, right, off the factory floor. Unfortunately, we don't have a video of that, but this is to show you that if you have the right information, all this can be extracted on site for prefabrication as well as for installation. Okay, so Leonard, can we move on to the other model? Okay, so just give you an idea what Leonard is able to do, to see. He can stretch, he can view, he can, look at the information in 3D. So next is we want to show you a huge model. This is the Golden Village development in Vietnam. Okay, so what has been done is the detail model was developed for 3 towers or 4 towers. And this is a huge model. And we want to show you that you can actually incorporate the architectural as well as structural in different layers, and you can view or you can switch off any layers that you do not want to see at that point in time, or extract information that's relevant only to you. Okay. And we are gonna do it. It's loading. It's a huge structure, so I'll give it some time. I know that I'm running out of time. I'm wrapping up soon, Sunita. This is the last thing that we're going to show you. So what's really spells out this extended mixed reality is that you're not just seeing the virtual world. Okay, as you can see, I'm in the NUS, one of the computer room. All right, so you can actually imagine if you're on site, you're doing a walkabout, you can actually do a street view. So now we're going to navigate to a street view. And we're going to show you how you can actually walk through and actually look at what's being done on site and what is required virtually. Okay, so you're in the basement, I believe. So he's looking at the virtually built structure in an immersive mode. You can maybe hop to the 2nd floor or teleport yourself to another floor if you can pick, the location. So he just have to point and then he's there. I don't know which floor this is, but you can see that there's a ramp. So he's doing a turn around instead of a walk around. Maybe you want to walk around before everybody starts to.
Yeah, so literally you are taking a context off the screen and putting it onto the job site.
Yes, so we don't have access to any job site right now. But what we want to show you is the idea that if you have enough data, right, you can actually create such a digitally monitored remote collaboration. And what Leonard is going to do is he can actually tap on any element, okay? Either he can find out more about the element or he can create to-do list, okay? So, so for example, if you detected any clashes or anything that is not fitting, right? You can take a snapshot and you can create to-do list. And this to-do list will send out to the assignee, be it an M&E guy, the engineer or the architect or the contractor, and they will receive it in real time via email. And when they receive that email, the context is there because they can see where the problem areas are. And then there'll be a tag to it that says whether it's conflict is resolved or is in progress, okay? And everything will be tracked. And at the end of the project, if you want to do a RFI, right, this is where you can actually export the entire list of the to-do list and who is responsible and what has been done, what's been resolved and what's outstanding. And all these can be for management review, right, and for approval as well.
Yeah.
So this is something that is done in real time. And we actually have people that's already using this all the way from prefabrication to delivery to site and the sign off and approval.
Hi everyone, my name is Sean Koo. So I'm actually the CTO of H3Zoom.ai, and we are the Artificial Intelligence and Digital Solutions business unit within H3 Dynamics. So H3 Dynamics, we are actually a startup founded in 2015 in Singapore. And really our focus over the course of 5 years has been looking at AI digital solutions, as well as working with robotics solutions such as drones. Over the course of 5 years, we have 24 patents filed, 5 granted, and we have a global team. So we are headquartered in Singapore, but we have an outreach in the US, Brazil, Mexico, and New Zealand and Hong Kong. So really the focus for H3Zoom.ai is applying artificial intelligence as well as drone technology for the condition monitoring of industrial assets. So as you know, the infrastructure or the state of infrastructure in the built environment is aging, right? And really our mission is to democratize the use of such technologies and really apply these technologies to speed up and to augment the condition monitoring of this large-scale infrastructure. So specifically where we've focused on for the past 5 years has been in the built environment, specifically in Singapore for high-rise buildings inspection, right? And I would say the core driving motivation behind the use of such technologies for building inspections is due to the fact that Singapore's infrastructure is obviously aging, as well as there's been a regulatory push from the Ministry of National Development, specifically on tightening rules for inspections of building facades, right? And really what we've done over the past 5 years is working with industry partners, regulators to push the adoption of such solutions so that we can, essentially elevate, the digitalization process of, the built environment. I'll just briefly go through what some of these upcoming new regulations are. So in the beginning of this year, there was a new law passed by the Ministry of National Development on a periodic facade inspection regime. So today, for those that are involved in the maintenance and operations processes of buildings, you might know of the periodic structural inspection, which takes place, every 5 years, where inspectors are on the ground, ensuring the integrity of the buildings are safe. Now, in addition to this periodic structural inspection, there is going to be a periodic facade inspection regime, right? So what this actually does is we are taking the facade and the building envelopes really seriously to ensure the integrity and safety of such, I would say, appendages inspected on a frequent basis. So why this is the case is because, over the past 3 years, there has been reported incidents of, I would say 90 reported incidents of falling facade pieces, right? So in order to keep to continue to keep our city safe, we've actually worked very closely with the regulators to basically review the existing inspection process. And what we found was, for this current existing process, it involves a couple of various stakeholders. So you have like engineering companies, you have architect firms, you have professional engineers, you have building owners. And typically the process of maintaining and inspecting the buildings would take anywhere between 4 to 8 weeks, depending on the complexity of the building, right? So, and what it costs to the building owners can be anywhere between $12,000 to $25,000, right? And bear in mind, this cost, could be just for the visual inspection component, or it could be, the physical inspection component, right? And really, from a inspection process, if I would say if you do not already know that the operational setup can actually be quite costly, right? So when we look at, building inspections, you could have a gondola, boom lifts, or even cherry pickers, with tight and difficult access to reach areas where some of these, I would say, inspectors have a hard time actually reaching, right? And since 2018, there's been like 17 work at height accidents, right? So looking at this pretty, I would say, archaic process, what we have done is, actually co-developed a solution with JTC, as well as we've worked with HDB and BCA to basically arrive at a solution that involves artificial intelligence, right, and the use of drones to improve the inspection processes by over 70%, and actually, increase productivity gains of some of these inspectors and managing agents by over 70% as well. And really, from a cost perspective, we've actually helped a lot of building and asset owners save over 50%. So, as the existing workflow today, consists of, elevation, diagrams. And really what is done today from a inspection process is literally we have inspectors on the ground, right? Observing and performing the visual inspection either through, a binoculars or a point and shoot camera. And they are literally marking, potential critical issues on a elevation diagram such as this, right? And really you can see the process is pretty inconsistent, right? And what we aim to do is to digitize this process using drone technology, right? To basically augment inspectors on the ground to reach areas where it would be traditionally difficult for them to reach, and to capture images or video files in a more comprehensive and holistic manner, right? So with drones as hardware, is being augmented by a flight path, I would say drone flight path automation software to speed up some of these inspection processes. Data that is being captured from the drone are automatically processed on a platform. And really that's where our machine algorithms actually get to work, right? So unstructured data such as images and video files are automatically distilled, and the computer vision algorithms analyze these images, segment the images, and flag out, let's say, critical defects and issues, right, to subject matter experts such as professional engineers or civil engineers to validate and review some of these data sets, right? And the consolidation of, I would say, artificial intelligence and workflow automation, right? We would be able to, I would say, portray the insights onto a web application that is later accessed by building owners, or could be facility managers or managing agents, to get an overview of the condition health of buildings, right? So if you could think about it, like, large property owners could have, hundreds and thousands of buildings, right? And today there is really no elegant way to manage the number of inspection jobs, the number of, I would say, inspection reports, as well as to get an overview or insight of, I would say, condition health of various properties located in, I would say, various locations, right? Be it Singapore or be it global. And really what the platform serves is to automate this process, give building owners insights so that they're able to, better allocate operational resources to specific assets and properties to rectify critical anomalies before accidents actually happen, right? So this is a video clip to demonstrate and illustrate the end-to-end workflow, right? So I'll probably just walk through. So today, so basically, as you can see here, the drone automation is actually, managed on site by, two drone operators, right? So we have someone who is looking at a console, and what the second drone pilot is performing is, ensuring that the flight path of the drone to be taken is set, and the drone automatically takes off, with a click of a button, right? When we talk about, full autonomy, this is what the technology is all about, right? So the flight path that is planned is automatically uploaded onto the drone, and with a click of a button, the drone is executing this flight path. And as you can see here, the drone is actually making its way towards, I would say, a building located in Fusionopolis, and it's going to undertake an inspection flight path. So from a augmentation perspective, the pilots are on site to ensure the safe integrity of the drone undertaking the inspection flight path. And from the pilot's console, they are able to see or have digital eyes, basically see through the lens of the drone that is performing these inspections, right? So traditionally, for inspections that to be done, you would have to send workers, on the top of the rooftop to basically manually inspect, the roof. And, it would take, it really depends on whether access is available, so on and so forth, safety permits, right? But, with drones, we are able to sort of reduce that barrier of entry, right? And once the drone completes the inspection, with the data, it's automatically, uploaded onto our platform. And really this is where the magic happens, right? Through several workflow automation and machine learning algorithms, the insights are ultimately shown on the platform, and the building owners are able to get insights such as, what is the total number of defects that were found, were there any critical critical defects, were there any defects that require a repair, so on and so forth. And really you can see that the images the images taken by the drone are automatically analyzed by I would say computer vision models, and the results are automatically mapped onto 2D elevation diagrams, right? And with thermal imaging, platform is automatically able to reference thermal images with HD images. And really over here, it gives an overview of the building condition, and the managing agent or the building owner is able to share and download inspection reports. So when we talk about I would say sharing of information with various contractors or vendors, if they have if they're working with a contractor that just looks at spalling concrete, then they would be able to share such inspection reports with a click of a button, and the inspection reports are automatically generated. So these these sort of like workflow automations and with machine learning we're able to sort of I would say expedite the inspection process and really help digitalize, I would say, help with the digitalization process of building owners and digitize the existing process for maintenance and operations work, right? So what is the software? So again, back to the some of the core products that we've that we've built. So essentially in that video that was illustrated, you could see that there were definitely certain algorithms that were used to plan, right, the drone inspection flight path. And really what these algorithms that we built is actually for a product called FlightMap. And what FlightMap actually does is FlightMap is able to ingest any 3D mesh model as a baseline. And with this 3D mesh model, we are able to extract valuable metadata, right? Such as were there any obstacles around the building? Basically, were there any I'd say could there be like weather conditions? With map layers layered on top of this mesh data, as well as perimeters from the drone, such as the battery health, the speed that the drone is that is supposed to be moving at, and really consolidate, and basically with all these parameters as I'll say consolidated, what the algorithms actually does is able to construct a unique flight path, right, for the drone, for any sort of complex structures. So what we mean by complex structures is, if we look at, a very unique architectural building like, the Singapore Indoor Stadium, right, with its, sort of, I would say, concave structural design, the flight path that is built, right, adapts to that shape. And what this actually does is it will enable the drone to perform the inspections at a even more comprehensive manner. Being able to take photos, right, at various angles that the current, I would say, process as compared to the current inspection process, right? And really what this does is it enables the inspection process to be speed up tremendously, right? So with drones, there is already existing time and cost savings, but with FlightMap, that basically improves efficiency by an additional like 50%, right? And this is just an example of a typical flight path that is planned for a for a building, and yeah, this is just to give you a visualization idea, right? So once data, right, is being once the images and video files are actually being captured by the drone, with flight map, it's then it actually gets I would say goes through several I would say processes, and really what we've developed co-developed with JTC over the past 3 years is a proprietary computer vision algorithm along with a rather sophisticated I would say data pipeline infrastructure. And the focus has always been are we able to identify anomalies and defects on building facades and building envelopes today, right? And these are just some examples of what the algorithms are able to flag out. So anything from concrete cracks to spalling, corrosion, buckling, so on and so forth, right? And I'll just go through, just to share what this proprietary, I would say, AI, I would say, infrastructure that we've actually developed. So we actually code name it ZoomNet 4, right? And really what, and just to give you a demonstration of how this actually works, say for instance, the images that are taken from the drone, once it's uploaded onto the platform, all that is all back end code and processed. But with this interface, it basically gives, I would say, users like yourself, what the AI actually sees, right? So you can see that from this image that was taken, approximately, 5 meters away from the building facade. You can see that the algorithms were able to identify several defects, right? Water stains, are one, concrete defects are another. And then so this is another, I would say, image. You can see that, just from this image alone, the algorithm is able to accurately identify and mark out these defects. And, this helps the, I would say, subject matter expert, right, speed up the process of validation and review, right? So, this is just an example. And just to share some of the other images that we were able to capture, right? So those images that are shown at the beginning of the video, those were images taken from the drone from the external facade. Now, what about images that were taken with mobile devices, right? So the algorithm works is able to identify some of these defects as well, right? So you can see that rust issues, and again a multi able to identify like multiple defects on one images, right? So these are just some of the, I would say, examples of how, I would say, artificial intelligence can be applied, right, for on-site, I would say, inspection, and really speed up these inspection processes, right? So I'm just going to skip ahead, and I'm just going to stop just like right here. So as you can see that those images that were taken, and really the application of our technology to date, has been the maintenance and operations phase of the entire building life cycle. Now, obviously, the solution that that has been developed can also be applied, for the construction phase, right? So, say for instance, for construction site, such as the one that you see here, how artificial intelligence can actually be used would also be, workplace safety, right? So when you talk about construction safety, this is just, I would say, a snippet and a teaser of how AI or how the machine learning algorithms can be adapted, specifically for computer vision. Besides, identifying defects, it can be used to identify objects as well, right? So identifying objects on site for construction safety, that is another potential, I would say, use case that we are exploring. Right. So let me just skip ahead. So once the images have been processed, right, and has been reviewed and validated by a subject matter expert, all this information is made available, right, on a one view summary platform, and really at a portfolio level. Building owners and managing agents, they're able to get this overview of the asset condition, right? Specifically to the number of inspections that were done, were there any critical or unsafe defects, right? And the sort of insights that they're able to draw, obviously defects that would basically defects that fall under the category of of require repair, that would ultimately translate into I'd say something that is unsafe or critical. And what really this really does is it enables the building owners and managing agents to plan ahead and to basically get a better overview of exactly where these defects are located on their building assets, so that with this information they can coordinate and work with repair and rectification vendors to better plan, right, rectification works in advance, right? So making this information more transparent would enable the asset owners to also save on costs. When it comes to issuing I would say RFIs and RFPs for rectification vendors to basically conduct some of these works, and as we accumulate more data, right, and basically for building owners, the over time they are able to review year on year the changing conditions of the buildings that they are managing. So if we talk about the implementation of proactive maintenance, right? You could think of a scenario where the drones are sent out there, doing this performing scans on an annual basis. The accumulation of this data year on year would be valuable data to the asset owner, because they are able to now get snapshots of the changing conditions of the building, right, over time. And really some of these I would say insights, right, to the asset owners would ultimately mean for them would probably be, okay, if specific assets are located in specific geographies, and if these properties located in these specific geographies are more susceptible to certain, I would say defects, then the sort of information that they're able to extract would be, okay, perhaps from an operational maintenance or operational perspective, there could be better allocation of a maintenance crew to that specific geography, right? And then, from a building life cycle perspective, the goal with such a platform and would actually enable them to to basically maximize the life cycle value of their assets, right? So over time, information such as this would actually save costs, for building owners. So this is, I would say, at the end of a byproduct of the platform is a system located defect mapping inspection report. So essentially, inspection reports, as shown in that video, the building owners can actually download an inspection report with the anomalies actually mapped. This can be shared and for review, right? So.
Yeah, okay.
Again, over the past 5 years, we've actually done, actually over the past year and a half, we've actually inspected over 250 buildings, and we've also accumulated over 14 terabytes worth of data, right? And in terms of images validated with validated over 4 million images, and really, as a young startup based in Singapore, we're extremely proud of this accomplishment. And just to share, some of our major clients here in Singapore includes JTC, HDB, Singapore Power, SMRT, and the Building Construction Authority. Right. So our anchor client and R&D partner for the past 3 years is JTC. If you do not know much about JTC, just to give you a brief intro, they are actually Singapore's largest commercial industrial development agency. And they are a co-development partner for the H3 Zoom solution, right? And really, the sort of benefits that JTC has actually, I would say, achieved by adopting, artificial intelligence, drone technology to help with the digitalization process.
Thank you so much for that, Sean. I'm sorry, I have to cut you short because
no worries.
we're really running out of time. But I think
Yep.
for people like me who have who's gone through the traditional method of climbing the hoists and gondolas, this digitalizing of the facade inspection is really a luxury. So how long does the drone scan actually take, and what's the level of accuracy in the data that's churned out? I mean, you mentioned about complex structures, the concave buildings. So how does that work?
Right. So that's a good question. So depending on the complexity of the asset. So for instance, if we are looking at a 150-meter high building, right, the drone scan can be done under 5 hours, right? So that is using an image-based scanning, right? Now, if we flip on the switch to use video, that process can actually be, the time saved, right, can actually be done within 2.5 hours, 3 hours, right? So when we just talk about the time savings from using drones, these are sort of the time savings that we're actually able to achieve. Now, from an accuracy perspective, the algorithms have been, I would say, that we've actually developed has an accuracy level of 92.51%, right? So that being said, we work very closely with professional and civil engineers in initial, I would say, training phases, right? And really what they've done is, basically, providing the subject matter expert and the insights into what some of these defects actually mean and stand, so that from a machine learning perspective, that is actually being ingrained into the algorithms. Right now, again, the sort of processes that we've actually built into our data infrastructure, there's actually a self-learning mechanism. Right. So over time, with accumulation of data and with accumulation of usage, the algorithms are able to be more refined. And the goal is actually to be at the goal is actually to get it to a point where it would be almost like a Siri, right? So if you're familiar with Siri, like basically it's this I would say AI application on your iPhone, where it could serve as a Alexa assistant, right, to help speed up some of these, I would say, validation and inspection processes, and review of, I would say, building facades, and I would say, basically building facades.
There was a question from our BeyondX audience, whether the scanning is able, from Alfred, whether the scanning is able to identify cracks that exceed certain allowable crack width.
That's a good question. So today, our algorithms are purely based on vision. So basically what this means is, if we are able to, basically from the images, if we are able to extract and extrapolate I would say, the image of the crack, or the image of a rust, or basically what constitutes to a water stain, the algorithm is able to identify. So regardless of how small or how big it is. Now, something that we're actually working on is that will answer to Alfred's question is adding the I would say the parameter where if it exceeds a certain size threshold, that computer vision would be would actually fire up and to identify that I would say that crack that exceeds, let's say, a 5 mm or 10 mm threshold. So this is something that we're working towards to.
Right. Thank you so much, Sean. Pei Ling,
No worries.
are you still there?
Yes, I am.
Okay, maybe a question to you. Do you think that wearable tech will replace tools on site? You know, like now we use the laser measuring tools and all. Do you foresee this being replaced?
I think in terms of technology, it's always improving and it's always enhanced. So what would happen is that as technology becomes more democratized and more affordable, things will start to move very fast. So in terms of replacing whatever we have now, or whether it's been enhanced, or whether like even for our XR10, right? This is already the second edition. So the first edition basically is a lot more clunkier and a lot more heavier and a lot more uncomfortable, and it's limited vision. So technology is always gonna be replacing or enhanced. So we think that at some point, some of the technology will be superseded, will become obsolete, and will be replaced by more integrated system. Like in our XR10, right? Besides being able to view the physical and the virtual world, you can actually hear as well. So what happens is we actually added the audio device where it's through bone conduction, so that when you're in a loud environment, okay, so this is the little audio device that actually sits at the helmet and conducts your voice. So while you're on site and you might have a very loud environment, you're in a loud environment, we can still communicate through the audio. All right. So this is what we mean by remotely, and all the technology will improve through time, and even the data will be refined through time. So more and more technology will take over, and we will make the site and the construction process completely seamless, right? Where right now, if you look at how architects communicate the model with the engineer and then so forth downstream, right? Some data needs to be recreated completely because we're in silos, we're working in silos. But with the constructible process, what we're trying to do is remove the silos, remove the boundaries, so that people can actually get the data they require at the right time and to collaborate and get things done right the first time. All right, so that will save time, increase productivity, and and save money, loads of money. Okay, that's the whole gist of technology moving forward. So yeah, and if you ask Prof. Chua, I think this is actually what he's passionate about, what he's working on, and what the Digital Revolution Fund is about, is to bring technology to the next level, and to also at the same time make case studies that's solid, that shows the results, the KPIs that will move things forward. So that's my answer. Prof. Chua, you have anything to add?
I missed your first part, but I just came in. But what you said about the second part, then when I hear it, I say that's what it is. I mean, the use of technology is to really improve the work processes. So, that's where the understanding of the process and then how the technology can actually play a part in smoothening the process, making sure, as what Pei Ling says, that data is not repeated and it is easy for collaboration, communication, and that is the whole design of how to use the technology with the process. The process may have to be redesigned, and that's where I think there must have this mentality. Otherwise, you're going back to the traditional approach, and then the technology becomes very cumbersome. Right. So this is the idea of how to. The important thing is how to redesign tasks such that this technology, or how to design processes in such that the technology comes in very seamlessly. That's the key about working together, collaborating, and making sure that this use case can actually be smooth. All right, and lean. That's the idea.
Okay, maybe one last question, Andy.
Okay, I will have a question to Pei Ling. Yeah, how well does it access the cloud? Yeah, inside the building, especially during the inspection on the construction building. Yeah, when we go down to the basement, let's say. Yeah, okay, that's my question.
So in terms of connectivity, when you mention basement, right, I think it goes with how strong the connection is that is available in the basement. As you can see, even now when we're going through the tunnels, right, sometimes we lose the signal. So all these will be improved, and we're talking about 5G coming in. So we don't know what 5G can do. Can it penetrate walls? You know, I no longer need an extender to my toilet when I want to use my 4G in the toilet or my Wi-Fi in the toilet. So all these things, right? I don't have an answer, but this is really good things that actually Prof. Chua is investigating and researching on. So we do want to test out our equipment when you are in a job site in the basement, and we want to inspect the services, the piping going through, to match whether the virtual, what we designed for, is actually being installed on site, right, for QC and QA. So that is something that above the ground, we don't have problem, okay? There's no issue in terms of seeing what we see on site versus digitally off-site or remotely. But when it comes to basement where there might be a disconnect in the Wi-Fi, that's something that we can't really do away at the moment, okay? But we can foresee that things will be, cloud is something that's happening and it's going to continue to be improved, right? So yeah, good question, but I think Prof. Chua will need to work on that with a real site in a real basement using our technology, and then to showcase the numbers from there.
Okay.
So if ONG&ONG you have a project, please let us know. We can just test it out and get the data out.
For sure, we would love to.
That's part of the fun of technology.
Yes.
Yeah.
Thank you so much, Pei Ling. I really wish we had more time for questions because I've got lots of questions, but we have to close up. We are running late already. So I guess we can all see how digital transformation in the industry is truly reshaping construction, and it looks like it is going to make a huge impact, and it's becoming more of a necessity, not so much a choice. So
just before we sign off, we will be sharing our slides with everybody. So let us know how to do that, and then we will send it to you.
We'll get in touch with you for that. Okay, so I'm afraid that's all the time we have left, and we hope that everyone has gained from today's session. Thank you to our BeyondX speakers, our audience on Zoom and Facebook for taking the time to be here. Please check our schedule for other interesting BeyondX sessions. And on behalf of my co-moderator, we will see you in the next cycle of BeyondX in July 2021. Thank you.